In section 12.3, we're going to continue our look at lateral area and surface area, but instead of looking at prisms and cylinders, we're going to look at pyramids and cones. These two have a very similar relationship with each other, just like the prisms and the cylinders had a very close relationship with one another. So we hope when we can connect these particular shapes together, it will make it easier for you to remember each of these. So let's look at this. First, we're going to be talking about regular pyramids. We are not going to discuss non-regular pyramids. We're going to leave that to any college geometry that you might take. I think you're quite capable of doing it, but we just usually don't cover the non-regular in high school. So that's the only reason. We just we have time to put in other things, and it's not going to be that significant for you at this point. So we want to talk about regular pyramids. Now, a regular pyramid means that we have a pyramid that has as its base a regular polygon. A regular polygon. Now, that doesn't mean that each one is going to be a square. In this case, they gave us one that was square. But we could also have a regular pentagon, or a regular hexagon, or a regular octagon, etc., etc., etc. So the example that they've given us here just happens to be a square base. Now let's look at all the pieces here, and these are really, really important for you to know. One good thing about the pyramid and the cone is you just have one base. And it's always easy to decide which surface is the base. The base is always a perpendicular distance from the vertex. So we know we have a vertex point. And when I bring in that perpendicular, when I go from the vertex perpendicular to the center of your polygon, that is going to be the altitude of the pyramid. Okay? Now, when I come from the vertex, let's see if I can get a brighter color, and I come, look what's different here. I'm coming perpendicular to the base edge. I am coming right down the middle of one of my triangular sides. That is the slant height that I mentioned in an earlier video that we would be using the lowercase l for. Okay, so my yellow piece is my slant height. Lateral edges are still where the sides intersect, and the base edge is still where the base intersects the sides. But we need to make sure right now that you know the difference between the altitude and the slant height, because it is very, very important. The altitude goes from the vertex straight down, but the slant height goes down the side of a pyramid. Okay, so watch that very carefully. We need to know that because look at our formula for our pyramid. Our lateral area for a regular pyramid is 1/2 the perimeter of the base times the slant height of the pyramid. Let's write these variables down here. The P is the perimeter of the base again. And L stands for slant height, which is the lateral sides height. It is not the altitude. Okay? All right, so 1/2 PL is our lateral area for a regular pyramid. Let's do an example. When I look at example 1 in my textbook, the question asks us, find the lateral area of a square pyramid. Okay? Again, let me just encourage you with everything I can to write the formula down. They want the lateral area, so let's write down. That means I need to find 1/2 the perimeter of the base times the slant height. Since the perimeter of the base, I have a regular pyramid, I have a regular polygon, that means I have 4 sides and each side is 4. So 4 times 4 gives me 16 as the perimeter of my base. My slant height here is 6. They just give it to me straight out. So when I multiply these together, I'm going to get 8 times 6, which is 48 square inches. Okay? Now let's look at guided practice number 1. Turn off the video, if you will, and see if you can do the guided practice by yourself. And then we'll do it together. Okay, I'm going to draw this. Now, not all of you are going to have to draw this out, but I'm going to draw it while we're learning how to do it. We have a regular hexagon as the base of our prism. So I'm going to draw a 6-sided, very poorly, unfortunately. You know what? I think I can do better than that, don't y'all? Let's have a 6-sided. A 6-sided hexagon. Let's put our sides in here. Drawing pyramids is not my forte, but here we go. All right, the lateral area of a regular hexagon with a base edge of 9. So I have 6 sides here, and each side is 9. And my lateral height, that is the slant height. That's what comes right from the vertex to the middle of a side. That is given to be 7. So my formula is 1/2 the perimeter of the base times the slant height is my lateral area. Well, I've got 6 sides. Each side is 9, so that gives me 54. And my slant height is 7. So it's going to give me 27 times 7. And when I multiply 27 times 7, I'm going to get 189. And again, that is square centimeters here. Okay? Now, just like yesterday when we had a prism, once we found the lateral area of the prism, I would then add 2 bases to get the total surface area. Well, we have the lateral area of a pyramid, but we just have 1 base this time. So we're going to take our lateral area and add to that 1 base. And that will equal our total surface area of a regular pyramid. Okay? So again, uppercase B means chapter 11. It means if I have a triangle, then I'm going to use either 1/2 the base times the height, or 1/2 AP. In this case, I'm going to be able to use 1/2 AP because we're going to have regular pyramids, which means that my base would be an equilateral triangle. Or I'm going to have a square, which is side squared, or I'm going to have a regular polygon. So I need to remember that when I find that regular base, I'm going to have to use some of my formulas. Let's look at some of the ones they've given us here. And they're giving us a lot of squares, which is okay, but we need to be able to handle things that are a little bit more complicated than squares. But let's see what we've got here with example 2. Find the surface area of a square pyramid to the nearest tenth. It tells me what I need to find, so I'm going to write down my formula that the total surface area is 1/2 the perimeter of the base times the slant height plus the area of the base. All right, now let's see what we've got here. We know that we have a square, so I've got 4 sides. Each side is 12, so I already know I have 48. I do not know the slant height. This time they did not give it to me. They gave us the altitude in our drawing. So I'm going to pull that little red triangle out down here so we can get a better look at it. That red dotted triangle that I'm going to dot as well just to let you see what I've pulled out. The altitude is 16. This piece on the bottom right here is half a way across that length that's 12. See, all the way across here is going to be 12. So from the middle to the edge, which is what I have here, is going to be 6. And I need the hypotenuse of this triangle, which is my slant height. So let's use the Pythagorean theorem that L squared is going to equal to 16 squared plus 6 squared, which means that L is the square root of 292. Okay, so when I go to my calculator and I take the square root of 292, I'm going to find that it's approximately 17.1. Then the area of my base, since it's a square, that's going to be 12 by 12. Now I'm ready to put in the calculator 0.5 times 48 times 17.1 equals, it's about 410.4 plus 144. And that's going to give us approximately 544.4. Now look at these differences here. Do you see how those are a little bit different? And the reason is when they put in the calculator, they did not round. They let the calculator carry that square root. Their answer is more accurate than mine because I let mine round off. So when you let your calculator carry your square root, you're really getting a better answer. Okay? Can we pause now and let you try to do, how about number 2A? Let's pause and let you work 2A. Our altitude in there is 9. Our slant height is 11. You're going to find the total surface area of that square pyramid. All right, first thing that we're going to do is write down our formula so that we have a focus. We want the total surface area, so our surface area, our total surface area is 1/2 the perimeter of the base times the slant height plus the area of the base. Let's plug in what we have. We don't have the perimeter. We don't have the perimeter of our base, and we don't know anything about our base yet. We're going to be able to find it, but we don't have it yet. So that is something we're missing. And then our slant height is given to be 11, and I can't find the area of my base until I know something about the perimeter. So once again, I'm going to lift out that red triangle that's in the middle. There's my altitude of 9. Here's the slant height of 11, that's the L. And here's halfway across the base. So if I use the Pythagorean theorem, I'm going to get to find half of the base. So, 11 squared is 121, and that's my hypotenuse. So I'm going to subtract from that 81, because that's the square of 9, and I'm going to get 40. So my side down here, is the square root of 40. Okay, so that means that if from here to here is the square root of 40, then the whole distance across is 2 square roots of 40. Okay, so if I have 2 square roots of 40 and I have 4 of those all the way around the base, then really I have 8 square roots of 40. Now notice I'm not rounding anything off yet. I'm going to let my calculator carry that square root. And then my base would be 2 root 40 quantity squared. Okay, so I'm going to put my calculator 1/2 times 8 on the square root of 40. And I'm going to get out of that radical symbol and multiply that times 11. And I'm going to add to that, and I'm going to put in parentheses 2 root 40. I'm going to leave the root by arrowing out, closing my parentheses, and I'm going to square that little rascal. Come on down, and I'm going to hit enter, and I'm getting approximately 438.3. And that's going to be square inches right there. Okay? Let's move along. We need to look at, and I'm glad they put this one here, we do need to look at what happens when our base is not a square. So we've pretty much learned what's going on, but what if we don't have a square for our base? We need to find the surface area here. Find the surface area of a regular pyramid round to the nearest tenth. Now what we have here is the same type of thing, but we don't have a square base. So again, since I'm finding the total surface area, I'm going to write down my formula. So my total surface area for my pyramid is 1/2 the perimeter of the base times the slant height plus the area of the base. Now let's see what we have here. We can find our perimeter, can't we? Because we have a 6-sided figure. It's a regular figure. Each side is 5, so we know that we have a perimeter of 6 times 5 or 30. And we also know our slant height, it's given to be 8. So immediately we have our lateral area, which is 120. But our base is a regular hexagon, so we need 1/2 AP to find that perimeter. Now what they have done from this drawing to this drawing is they just pulled off the base so you could see what was going on. Okay, so we have a regular hexagon. Remember, one of the first things we want to do is find that central angle and divide it in half. That's where the 30 came from. That 30 is then formed by the apothem and a radius of that hexagon. So what we're going to do then, we know that the apothem cuts a side in half, so the 5 became a 2.5. We have a 30, 60, 90 triangle with a short leg of 2.5. The apothem is the long leg, so my apothem is going to be the short leg times the square root of 3. Now they use trig, which is fine. Okay, so we're going to have over here the area is 1/2 AP. That's 1/2. Let's see what our A works out to be. In my calculator, I'm going to put 2.5. 2.5, and then times root 3. Arrow out of that. So I'm going to get about a 4.3 for my apothem. And then my perimeter is 30, still 30. So 4.3 times basically 15 is 64.5. Okay, so for my base, using 1/2 AP, I get 64.5. Therefore, when I put those two together, that's going to give me a total surface area of 184.5 square centimeters. Alrighty? Are you good with that? Okay, why don't you pause now and see if you can do 3B by yourself. Let's just take a pause and do 3B. Okay, how did it go for you with 3B? We still need to write our formula. I want you to know what you're looking for. So we're going to have 1/2 PL plus area of the base. I do have enough information to find the perimeter of the base. I have a 1, 2, 3, I have a pentagon. Each side is 4. So 5 times 4 gives me a perimeter of 20. I do not have slant height, I have altitude. And so I'm going to have to find the slant height, and I'm going to have to find the area of my base, which is going to be 1/2 AP because I have a pentagon. Let's see what we can come up with first. Okay, if I go, trying to decide which I want to do first. I think the first thing that I'm going to do with this one is redraw. Ooh, that's kind of bad. Sorry. So all my sides are 4. I'm going to put in my radii. Okay. And I want to find an apothem. I'm going to put the apothem in yellow, I think. Okay, now whatever one apothem is in this guy, all apothems will be. I'm going to take 360 and divide it by 5. That will give me my central angle. These are probably sticking in your head by now. So that's 72 degrees, but the apothem cuts it in half. So that little angle is 36 degrees. Okay, let's use that little angle to find the missing pieces of our triangle. Okay, I've got a 2 here and a 2 here. So my opposite side from 36 is 2. I want to find the apothem. So if I want adjacent and opposite, that's the tangent. So I'm going to have my tangent of 36 degrees equals opposite over adjacent. So that's the apothem. So to find my apothem, I'm going to divide 2 by the tangent of 36. So 2 divided by tan 36, make sure you're in degree mode. It's 2.8. So I've got an approximate 2.8 for my apothem. Okay, so over here, I can put in 2.8, can I? And my perimeter, I knew that was 20. Could have put that in a while ago. So I've got my area of my base, but how am I going to find that slant height? Well, look at what happens here, and I wish I could blow this up and not destroy the rest of my notes here for you. But do you see that I can complete a right triangle by putting in the slant height? I'm going to put it in red, going right through the middle of that side. I'm going to go there, and putting in an apothem. That completes a right triangle. So I can use the Pythagorean Theorem, the altitude squared plus the apothem squared equals the slant height squared. Okay, so I'm going to have 49 plus 2.8 squared, which is 7.84. Okay, equals my slant height squared. So 49 plus 7.84 is 56.84, and I'm going to take the square root of that. Okay, so my slant height is about 7.5. So now I can fill that in up here. So I'm ready here to do my calculation. 1/2 of 20 is 10, so 10 times 7.5 is just 75. And 1/2 of 20 is 10, so I'm going to get 28 here. So when I add these together, I'm going to get about 103 square inches for the total surface area of that regular pentagonal pyramid. Okay? We're ready to shift gears to cones. Cones are a little bit easier, just like I thought cylinders were easier than prisms. So again, with the oblique cone, I do want you to know what it is, but we're not going to spend our time. We want to spend our time on the right circular cones. With our right cones, again, we're going to find our lateral area of our particular cone, and we're going to add the base. But in a cone, our base is going to always be a circle. Let's turn on to the next page and see what we're talking about. Okay, now you can follow through this derivation of the formula. It's really interesting, and there's enough information there for you to understand, because we've talked about these ratios being equal. So you can see where they come up with these areas. But and look at that yourself, but suffice to say, we're going to go on to what the lateral area is. So to find our lateral area of a cone, that's just the ice cream cone without the circle on it. Okay, there's no ice cream in it. It's an open-ended cone. Okay, the top is not there. So when we look at the area of an ice cream cone, then that area, that lateral area, is pi r times the slant height. Now, it is not pi r squared. This explains to you, it's not pi r squared. It's not 2 pi r, okay, because the 2's are going to cancel out. It is just pi r times the slant height of the cone. Then, to find the total surface area, we're going to use that pi r L, which is our lateral area, and add to it a circle, which is the base. So that's going to be pi r squared. So pi r L plus pi r squared is your total surface area of a cone. Let's look at the example they have here. When I look at this cone, they ask us to find the lateral area. So my lateral area for the cone that they've given me here, again, write your formula, pi r L. You know what? I'm going to leave that as pi so that I'm not rounding off. So to be more accurate, we're going to have pi. The radius of our base is 12. We don't know the lateral edge or the lateral height, which is again the slant height, but we do have enough information to use the Pythagorean Theorem here to find it. And we see that our slant height is 20. Now when I plug in and solve using my calculator, I'll round off at the end. I'm going to let the calculator carry that entire length of pi. And then I'm going to round off, and I'm going to have that my lateral area is 754 square feet. If I want to put the base back on, then I would take that 754 and add to it pi r squared to get the base back in. But that's not what they asked us to do here. Let's look at another example on the next page. Okay. Find the surface area of a cone with a diameter of 14.8 centimeters and a slant height of 15 centimeters. Drawing the picture helps so much. And we've got to find the surface area, so when I write my formula for my total surface area, it's going to be the slant height of a cone plus the base of a cone, which is always a circle. Let's see what they've given us. Pi, the radius is going to be 7.4. We can do that in our head. The slant height is 15. And then our pi, again, the radius is 7.4 squared. When you put that in your calculator, use your symbol for pi until you get to the very end, and then round off at the very end. See if I'm dropping that in your calculator, you get 520.8 when you round off at the end. Don't put in 3.14. Carry your pi with you. Okay, with that in mind, stop the stop the video and see if you can do 5B by yourself. Okay, we're going to find the total surface area here, so let's see what information we have. Again, we're going to use the radius of the base is 6, L we do not know, and over here we're going to have 6 squared pi. So we've got to find the slant height, and it's going to be easy to find using Pythag. See how that's the hypotenuse? So we're going to 6 squared plus 7 squared equals L squared. So I'm going to 36 plus 49. I'll put that in my calculator. It's 85. So I'm going to get the square root of 85 for my slant height. So I'm going to put in, to put this as accurate as possible, I'm going to multiply the square root of 85, I'm going to arrow out of that radical, times 6 pi plus 36 pi. And I'm going to get approximately 286.9 square inches. Now look at the bottom of this page. There's a beautiful chart here that's going to help you memorize these formulas. And look at how they're related. The prism and the cylinder are closely related, and then our pyramid and our cone are closely related. You're going to have to memorize those. You will not have a formula sheet. You're going to learn these because you're honor students and you need to be able to know these or figure them out, okay, because we're looking at ways to figure them out. I think we're about done. Let me go to the next page just to make sure that we're in good shape. Yeah, that starts your homework. So I think you're in pretty good shape now to handle this section. So we will see you Thursday when you can work some of these problems and have questions ready for me if there was something in here you didn't understand.